Welcome back. This is part 3 of microservices in NestJS. In this video, we'll be migrating our microservice from using the basic TCP transport over to a message broker, Redis to be specific. If you recall back to the first video, I said that the available transports could be reduced to 3 categories: basic TCP, message brokers, and gRPC. I say this because regardless of which message broker you use, how you code your app will remain the same. Now, gRPC is a different approach altogether, but we could almost group TCP and the message brokers together as one because there is actually very little difference between using TCP or one of the message brokers, at least from the perspective of how you code your app. Let's take a look at that process. The code you see here is the code that you would use to communicate with a microservice, regardless of whether the transport was TCP or one of the message brokers. The common scenario is that your app receives a request, it realizes that it needs to use some microservice to fulfill the request, so it gets a reference to the client and requests that some action be performed. The microservice uses the pattern provided to it to map that request to a specific controller method. Some code gets executed and a result is returned. Your app then does something with this result. In this example, I'm only logging it to the console, but normally you would do something more meaningful before returning that response back to the user. The coding process is exactly the same. The difference between these two is that basic TCP transport directly connects the client to the microservice, while with the message broker, you're inserting an intermediate component between the two and routing all communications through it. But, of course, this begs the question, why bother with a message broker at all? It's a valid question. I mean, if we have a microservice that was pretty simple to set up and is working just fine, why complicate things by adding a middleman? What value does this add to our solution? Because it must have some value. Otherwise, we're just adding cost and another possible point of failure in our system, right? A message broker adds value by decoupling our components. As it stands right now, our client needs to know about the microservice's existence and how to contact it. If we move the microservice, we need to ensure that the client's config was updated as well. With only one microservice that does not depend on any other microservices, that's a simple enough task to accomplish. But what happens when you have hundreds of microservices in your system like Netflix does? Clearly, when dealing with microservices, it's important to think about how your design decisions impact the complexity of managing the system that you are building, even if you're not operating at Netflix scale. One of the ways that you can make operational management of your system simpler is by routing all communications through a single point. When things go wrong, instead of tracking down a particular microservice or client and monitoring the TCP communications, you can just go straight to the message brokers to observe what's happening, or not happening, depending on what the situation is. Hopefully you are convinced at this point that adding a message broker is not a total waste of your time. But even if I have convinced you, you may follow up with, well, okay, but why choose Redis? And that too is a perfectly valid question. NestJS supports other message brokers, and using them is really no different than using Redis. It's just a matter of changing the values in the config object. There is one caveat in that NATS has some limitations. I'm not going to go into it, but it is detailed in the docs on the NestJS side if that's what you're using. So other than that, why choose Redis? Well, there's several reasons you'd want to choose Redis. First and foremost, it is incredibly versatile and feature-rich. While the other message brokers are only message brokers, Redis is an in-memory data store that provides a lot of different data structures, pub/sub features, and as of version 5, it even supports Kafka-like streams. These features can be used as building blocks for all sorts of solutions, such as job queues, sessions, caching, time series analytics, domain event broadcasting. The list just goes on, and the possibilities are almost endless. In my professional life, I work as a solutions architect, and I cannot tell you the last time that I delivered a solution that did not involve Redis in some way or another. Second, being an in-memory data store, Redis is lightning fast. In my production environments on Azure, I can get 2 millisecond response times right out of the box. That's with no optimizations performed. In a local dev environment where I'm not worrying about a network latency, the response time is measured in microseconds. Redis is incredibly performant and as such is a great component to have in your system building toolkit. Installing Redis locally or on a virtual machine is as simple as running apt-get install Redis server on Ubuntu or brew install Redis on a Mac. I'm not a Windows user, but I presume that it's not hard to install there either. After installation, it's already running as a service in the background, and we just use the installed Redis CLI to directly communicate with it. If you don't want to use Redis and install it locally, you can also get it as a service on any of the major cloud platforms. Azure, AWS, Google Cloud, they all offer Redis as a service. In fact, even DigitalOcean will be offering Redis as a service soon, which will open up a lot of new exciting possibilities for their users. So it may feel like I'm trying hard to sell you on Redis, and that's true. I think Redis is an awesome tool and I want you to use it to build great things. If I haven't convinced you yet, let me try one last shot with a little bit of peer pressure to see if that does the trick. In Stack Overflow's 2019 survey results, Redis was ranked #1 as the most loved database by developers. Given my experience with Redis, this is not surprising at all. It is simple, efficient, and just a joy to work with. Oh, and Redis didn't just make most loved database for 2019. This is actually the 3rd year in a row that Redis has been ranked #1. So developers love Redis, but how many professional developers are actually using Redis? The survey results show that over 20%, in other words, over 1 in 5 professional developers across all programming languages are using Redis. Redis has widespread adoption across just about all of the major programming languages and applicable frameworks. And due to that widespread adoption, client libraries are available for all major programming languages, making it super easy to integrate into your app, even if the framework you are using doesn't have built-in support for it. At this point, I promise I'm finished with evangelizing Redis. Now it's time to actually make the switch. In order to move from basic TCP to the Redis transport, we will need to install Redis and then update the microservice config object in our HTTP app and microservice. Let's switch over to the terminal now to quickly install Redis before jumping into VS Code to update that config object. To install Redis, I've opened my terminal on my Mac, and I'm just going to type brew install Redis. Now I'm not going to actually run this command because I already have Redis installed, but if you have a Mac, that's how you're going to install it. If you're going to be installing this on Linux or perhaps on a Linux VM under Windows, I'll show you how to run the same command with apt-get. So here I am on one of my Azure VMs, and I'm just going to type sudo apt-get install Redis server. Now I'm going to actually say no because I don't want to install that because I use Redis as a service. But if you wanted to install that on a VM, that's how you would do it. Now let me exit back out of this VM into my terminal. So now Redis is installed, right? Either on your Linux VM or on your Mac or perhaps on your Windows computer. To verify that it's installed and everything's working properly, we can just open up the Redis CLI. And if you connected just fine, then you're good to go. With Redis installed, it's now time to jump into VS Code so we can change our config object to tell it to use the Redis transport rather than basic TCP. So I'm in VS Code now, and if I open the terminal, I can see that I'm on the micro.app repo. You can find in the comments a link to this. However, if you've been coding along with the previous videos, this is where we left off. So we need to make a small change to our micro.app repo. in the main TS file. We're just going to replace this config object where it says transport TCP and provides a host and a port. We're going to replace that with this right here where we changed it to transport.redis, and the only option we pass is a URL string. And other than adding Redis as a dependency, that's all we have to do here. Now I'm going to switch over, well, first I'm going to save my file, and then I'm going to switch over to our http.app repository. Here I'm also going to add Redis as a dependency. And then in the service file, because this is where we're instantiating the client proxy, this is where we're going to find the config object. And the same thing, I'm going to paste in the exact same options. Let me just clean that up. We're going to pass in the exact same options. We're going to save, and that's it. That's all we need to set this up. All we need to do now is to run our basic test by booting the microservice, and then booting our HTTP app, and then using our client. I'm using Insomnia, but you can use Postman to hit our HTTP app with a post request and see if it accepts that request, makes the call to the microservice, and returns the result. Same setup as we had before. In the left terminal I have our microservice set up. In the right terminal our HTTP app that uses that microservice. And down here is my Postman style client, which I'm going to use to send a post request to the HTTP app. First I'll start the microservice. I can see that microservice is listening. So now let me start the HTTP app. Okay, my Nest application has successfully started. So at this point I'm going to hit it with a post request. This time let me just give it, let's say, 3 6s. I hit send. I get 18, which is correct. I can see here that we logged the request as it was received in the HTTP app, and same thing, and when it requested the information from the controller, we can see that we get the logging there. So everything is working just as expected. Our Redis setup is complete, but before signing off, I wanted to mention a few things that I didn't explicitly cover in the series so far. First, the microservice we set up listens for a request and returns a response. However, there are scenarios where you do not need or want a response. An example is a logging service. A logging service will listen for events and log them, but there's no need to send a response. For those cases, you can use the event pattern decorator instead of the message pattern. If I look at the docs under microservices and basics and the subheading event based, I can see an example of how to use the event pattern. It's very similar to the message pattern. And if I scroll all the way to the bottom, I can see how we use this from the client side. And the only difference really is that instead of calling send on this .client, we're calling emit. Number 2, NestJS Microservices are not constrained to communicating with other Nest projects. You can communicate with any app written in any language. Some may be simpler to set up than others, but language is not a barrier. I use Laravel and Redis a lot, so I'm interested in connecting those two. I saw some communication on GitHub about providing documentation on how to do this, and I hope they publish it soon. Once published, I'll certainly make a quick video to demonstrate. And lastly, have I told you that Redis is amazing? You should really start using it. So that's a wrap for this video. In the next video of this series, we'll dive into gRPC, a really cool approach to inter-process communication that was initially developed by Google, and we'll learn how to use it with NestJS. Until then,